Welcome back to Einstein's mechanics. In this episode, we are going to solve problems using the comparison test to test if a given series converge or diverge. So here in example 1, it says use the comparison test to determine whether the series converge or it diverge. So let's see, we have a given series. So straight away, we know the rules of the comparison test. So this is I have it this way, which is 2n on 7 plus 8. Are we okay? So I can compare these two, we have to compare to a second series, n is equal to 1. So here we can see that when n is approaching infinity, adding 8 is what? Insignificant. So we can ignore the 8. So this can be written as 2n on 7n. Are we okay? So between these two, which one is the largest? We can see that if the denominator is increased by 8, we are going to reduce the whole equation. So this is going to be the smallest. So I'll represent this by an, and this is going to be the largest, which is what? Bn. Are we okay? So I can say from the Bn series, what we are going to see that this series can be written as summation as n is equal to 1 to infinity of 2 on 7 all raised to the power what? N. Now, what can we compare this to? This is a GP, right? A GP series where our ratio, common ratio is going to be what? 2 on 7. Now, 2 on 7 is less than 1. Anytime we have a GP such that its common ratio is less than 1, what happens? We know that that series is going to what? Converge. Therefore, Bn converge. Are we okay? So by the rules of comparison test, if the bigger one, the bigger series, which is Bn, converge, then automatically the smaller series here is what? An. It also what? It also converge. Therefore, this whole series, which is the smaller one, An, is going to what? Converge. Are we okay? So after testing, this series is going to what? Converge. Very simple. Now let's look at example 2. Example 2, we are still using the comparison test to see if this series is going to converge or what? Diverge. So what do we have here? Now this is our series. Please pay attention. N is equal to 1 to infinity n plus 5 on n squared. Now we have to compare this to a second series, right? So n is equal to 1. How are we going to write this? We have our n squared. So for large values of n, adding 5 will be what? Insignificant, so we can remove it. This is going to be what? N on what? N squared. Now we know that this is the same as what? 1 on n. Is that true? Yes, this is the same as 1 on n. Now when we compare these two series, this and that, which one is going to give us large values? Now because even if we compare from here, this will be simple. Now we can see that the numerator is now increased by what? 5. By here, the numerator is not increased by any value. That means for the same number n squared dividing the number, this is going to have bigger answer. So this is going to be the bigger one, which is Bn, and this is going to be the smaller one, which is our what? An. So now we know that our An is this series, right? N is equal to 1 to infinity of what? 1 on what? N. Now we can test for the convergence or divergence of this series using what? Using the P test. Alright, so With a p-test, what do we see? We can see that the n is raised to the power 1, where that is our k is equal to 1. And what did we say? If our k is equal to 1, that means the series is going to what? Diverge, right? If k is equal to or less than 1, the series is going to diverge. Therefore, an, it diverge. So what do we know from the previous episode? The rules of the convergence test or the comparison test. What we are saying, if the smaller series is divergent, therefore the bigger series is also going to diverge. Therefore, so this is if the smaller series, so the smaller series, which is our an, diverge, then the bigger one, then the bigger series, which is our bn, is also going to what? Diverge. Therefore, the whole series given is what? Is diverging. It diverges. So bn diverge. Are we okay? Very simple. So now let's look at the third example. Alright, so now we have this summation from 1 to infinity of this series given. So straight away we will write down our series, which is summation from n is equal to 1 to infinity 1 on the square root of n to the power 4 plus 5. Are we okay? So now we can compare this to another series, n is equal to 1 to infinity on 1 square root of n raised to the power what? 4. Because large values of n plus 5, that means the 5 will be taken out. So we can compare it to this. Now between the two, which one is going to give us the largest? We can see that the denominator is now increased by 5 here, which is going to reduce the answer. That 5 is taken out from this side. So we are going to have bigger answers from this as compared to that. So this is going to be our bn and this is going to be our an. Now look at the series bn. We can further reduce it, right? So bn is the same as this. N is equal to 1 to infinity 1 on. Now square root is what? Half on 2, right? So this is the same as 1 on what? N squared. So therefore our bn is now summation from n is equal to 1 to infinity of what? 1 on n squared. So what can we say? We know if bn diverge or what? Converge from the p series, right? Yes, we can use that using the p-test series. So if here our k is going to be equal to what? 2. And if k is equal to 2, then our bn is going to what? Converge. Bn is going to converge. And since the bn, which is the larger one, is converging, therefore the an is going to what? Converge. Alright, so this whole series is going to what? Converge. Very simple. Let's look at another one. Example 4. We have this still using the comparison test to see if this is going to diverge or it is going to converge. So straight away, I have my summation from 1 to infinity of 1, 7n squared plus 4. What can I do? I can compare this to a series summation, which is n is equal to 1 to infinity 1 on. If n is large, then we can ignore plus 4, right? Or even multiplying by the 7. Is that true? Yes. So we can get straight away n square. Now, with this, which one is the largest? This is going to give us the largest. This is going to be our an, the smallest, because for equal numerator of 1, this one is going to divide by large number as compared to this. Alright, so Bn, from Bn, what can we say? Bn is this series. So Bn, summation n is equal to 1 to infinity 1 on n square. Using the P series test, then our k is going to be equal to what? 2, meaning Bn what? Converge. And what does it say? If the larger one, Bn, if Bn converge, then our An, which is the smaller one, is also going to what? Converge. So the series converge. That's very simple. All right, let's look at the last example with the comparison test. So we have this. We are to determine whether it converge or diverge using the comparison test. So straight away, just as we do, I'll write my series from this n is equal to 1 to infinity on 2n cubed. Please pay attention here, n square. Then I will try to compare this series to, so here I can say this series can be compared to this one, n is equal to 1 to infinity n, because for large value minus 1 is not counting, right? So I can also say, still for large values, I can say n cubed plus n squared. Is that it? Yes. Now we have this format. So how do we make it look like a P series test? So here what we can do is we can pick, for large values of n, we can pick two form, this and that. Are we okay? So that we can solve, because we know that the n cube is the largest among the n. Are we good? It's large as compared to n squared. So we can say that we are now comparing this whole series to this. We are comparing it to summation of n is equal to 1 to infinity n on n cube. Is that it? Yes. Now this is going to give us the same as 1 on what? N square. Now this one, I'm assuming this is going to be what? Insignificant, because I have a larger what? N as compared to that one. So this is now also going to be our Bn. Then this whole series is going to be the smallest, which is what? An. Now, just as we did by the P series test, the k is going to be what? 2. And for values of k greater than 1, then the series Bn is going to what? Converge. Then if Bn is converging, then An, which is the whole series summation, n is equal to 1 to infinity n minus 1, 2n cubed plus n squared, is also going to converge. Alright, so this is few examples solved using the comparison test. So we always compare to a new series we derive from the existing one. Thank you for watching this episode. Please subscribe to the channel, like the video, share, and see you in the next episode for limit comparison test tutorial. Thank you.